Today we'll be learning about two special sequences. Just to start off with, a sequence is a string of objects like numbers that follow a particular pattern. As I stated, we're going to be going over special sequences, and these are going to be dealing with patterns of numbers. Our first one, our arithmetic sequence, is a sequence where each term after the first is found by specifically adding the previous one by a fixed non-zero number called the common difference. For example, if we look at this sequence 5, 8, 11, and 14, each one of these increase by a value of positive 3. So we would say they have this sequence has a common difference of 3. Another special sequence is a geometric sequence. A geometric sequence is a sequence where each term after the first is found by multiplying, which this time we have it bolded just for extra emphasis, multiplying the previous one by a fixed non-zero number called the common ratio. So if we look at this first part right here, we are talking about multiplying, so we don't want to say it's just being divided. This would be a difference of a negative 1/2. We're going to start breaking down our division into the multiplication version. So instead of saying divided by negative 2, we're going to say that we're going to be multiplying by negative 1/2. If we check the next one, yet again, that is a negative 1/2 for the ratio, and so on and so forth. Now, with these two special sequences, we can start looking at sequences of numbers and trying to figure out if they fall in line with either one of these, where we add a fixed number or where we multiply by a fixed number. For the we do, it asks us to follow each of the following, or for each of the following, identify if the following sequence is arithmetic, geometric, or neither. There are plenty of other sequences out there. We're just focusing on these two, or if it is something else. Possibly something else. State the next 4 terms in the sequence. So we're going to continue whatever sequence we have. And then we want to identify the common difference if the sequence is arithmetic, or a common ratio if a sequence is geometric. So looking at our first one, we can break it down either way. Just to start off with, we're trying to see if there is a pattern. Easiest one is arithmetic. We can see that goes down by negative 2. So if all of our other numbers also go down by a negative 2, then we know this follows the pattern. Now you need to make sure that you check all of the numbers that are given, because some of them might change in value, which could show that it could be geometric instead. But in this case, we see all of them are adding a negative 2 to get to the next number. So we are going to say that this is arithmetic. That means for our next one, we would do 4 plus a negative 2, which is 2. Next one would be 0, then our negative 2, and then our negative 4. And we could continue this process on infinitely. For our next one, if we tried arithmetic, this would be a plus 2. And then our next one would be a plus 3. Since these are not the same numbers, arithmetic does not work. Geometric means that we're multiplying. Now the easiest way to see what a number multiplies by to get a new value is just doing the opposite. Take our product, the 6, divide it by 4, and it will give us our fraction. which in this case is 3 over 2. If I multiply 6 by 3 over 2, that does give us 9. But if I try it on the next one, that does not work. It ends up being 13.5 if we were following that pattern. So geometric does not work as well. So this pattern would be a neither. This one follows a different sequence where we are adding by 2, and then we're increasing that value by 1 every time that we add. But in this case, that is neither one of our special sequences, so we just circle neither. For our last one, if we went by arithmetic, this would be adding a negative 18. And our next one would be negative 9 added, which does not work out. So we know arithmetic is out. If we do geometric to show it, it is going to be 1/2. Yet again, multiplying by 1/2 would give us 9. Multiplying 9 by 1/2 would give us 9 over 2. So this time we have a geometric. Our common ratio is going to be 1/2. And to continue the sequence, when we multiply each number by 1/2, our following sequences, we're just going to be multiplying the bottom. So 9/2 times 1/2 would give us 9 over 4. Then 9 over 8. 9 over 16. And then finishing off with 9 over 32. So, even though that we went over only two, the arithmetic, where we are adding a set value, and geometric, where we are multiplying a specific value, there are still some others out there. Number 2 does not follow either one of that. That's why we chose neither. We would start looking into other possible sequences in order to find out its given values, or sequence.